Now the quantum mechanical model will determine the allowed energy an electron can have and how likely it is to find the electron in different locations around the nucleus. Now this might seem like, what are you talking about? But I think as we get through it, it's pretty difficult, but if we get through it and we give you examples, then I believe it'll make a lot more sense. So let's look at atomic orbitals now. Now before we just had energy levels. So we had the nucleus and then energy levels. But what they found is that we can split up that energy level into sublevels or suborbitals. And there are 4 types of orbitals. The first type is an s orbital. And it looks like this in a sphere. S orbital holds 2 electrons. Okay, so only 2 electrons can be in an s orbital, and they're buzzing around there somewhere in here. So we're not exactly sure where, but somewhere they're buzzing around in this spherical region. A p orbital, and you can't really see, I think there's probably a better diagram in your book on page 131 of a p orbital. P orbital looks kind of like an airplane propeller, but it has 3 basic little wings to it, I guess you could say. So one will go off in the x direction. So we have x direction. There's in the y direction, and then back in the z direction. Okay, so each of these will hold an electron. So we have 1, 2, 3, 4, 5, 6. So somehow, if we can imagine these electrons buzzing around in all these different directions, so orbiting like this in these areas, you can follow the way it's going. So just imagine electrons, 1 electron per bulb, flowing around like that. So p orbital will hold 6 electrons. The d orbitals, you can't see one coming out here. So the d orbital holds 10 electrons. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So somewhere in this space, these orbitals hold 10 electrons. They're moving around very quickly, and this is the likelihood of where they will be. So this whole thing, these are not electrons. These are clouds of where, like airplane propellers, where those electrons might be. Somewhere in here. Right, so the d orbital will hold 10 electrons. The f orbital, if we have 1, 2, 3, 4, 5, 6, 7, we can guess what they hold. They would hold 14 electrons. Now knowing this, we can break up those energy levels into sublevels, and we can see where the electrons are most likely to be. And also what this gives us is a much clearer picture of bonding and of characteristics of groups and families that we'll get to. When we get to chapter 6 and 7, etc., this will really make sense of, wow, okay, so these families and columns, or these groups, are basically this very similar because of their orbitals. Okay, so this is another diagram of the orbitals. The s orbital is easiest probably to visualize. It's just a sphere of these. So we have 2 electrons moving around somewhere in this sphere. In the p orbitals, we have electron, 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 electron. We have 6 electrons moving around in these different axes, or axes. In the d orbital, we have 10 electrons moving around. 2, 2, 2, 2, 2. So these are regions of where those electrons would be. So again, these little jelly beans are not electrons, it's the region of where those electrons would be. And in the f orbitals, here are the regions where we can see where those electrons might be. It's just another diagram Kind of nice little colors and everything. And some more diagrams of those orbitals. Another pictorial representation. We don't have F here, but we have the P, where those electrons would be, and the D. This is, I think, pretty cool. I think it's really neat. You can see the orbitals, the Orbitron gallery of orbitals. You can kind of see where hydrogen just has one electron, so it just has basically a half a region of an s orbital. And so you can see how the orbitals compare. And once you get to know where these electrons are situated within their orbitals, it would make more sense. It would be much more exciting to see this. Now it's probably like, yeah, so what? So if we look back at the Bohr atom, we'll see that we have energy levels here. Now each energy level corresponds to an orbital, these things, of a different shape, which describes where the electron is likely to be found. So the electrons, again, are somewhere in this region. And we can see these types of orbitals. Here we have the orbitals. So these are the sublevels right here. And we'll go over which ones are what. For this nitrogen atom, it has an s orbital. The first energy level 1, is s orbital. The second energy level, this is a 2s. Second energy level has an s orbital as well. Then the third one has a p orbital. P. This is the p orbital. And it can fit, and we can see the number up here, it has 1s2, I'll write it larger, and it has 2s2, 2p3. So that means there are 2 electrons in the first energy level, in the s orbital. Here's 2 electrons. In the next energy level, the second energy level, in the s orbital, there are 2 electrons, as we see right here. 1, 2. So then there's 1, 2 there. In the third, or also in the second energy level, the sublevel P, there are 3. Here's a sublevel. This is still second energy level, but it's a sublevel. So this is a new way, more exact way of looking at where those electrons are. So if we have this one big atom here, it's going to be comprised of energy levels with different sublevels which have orbitals in it. So here we have the nucleus of the atom here. The 1s orbital, it's hard to see the nucleus, but I'll try and color that a little. It's like right in the center. The 1s orbital is the blue region. That's the first energy level, and that only has an s orbital. The second energy level has a s orbital here and a p orbital. So the second energy level has an s and a p orbital there. The third energy level goes up to a s. So we have a big s, round spherical energy level. So these are where the electrons will be. Again, each energy level will have sublevels which have corresponding orbitals in it, or shapes of where those electrons would be. Now where those energy levels will be, we'll get to, but let's just look at this in a little more detail. So if we have an atom, our Bohr atom, which we have drawn before and we should be pretty good at doing, let's look at a let's look at aluminium. That's how they pronounce it in England. So we have 13 and 27. So we have the aluminium atom, we have 13, 13, 14. So in our nucleus we have 13 protons, 14 neutrons. The first energy level, and again we'll show you how the order is in all of this coming up. first energy level, that's the first energy level, has an s orbital only. So that has 2 electrons in the first energy level, and it's 1s with 2 energy levels, or 2 electrons. First energy level only has 1. And again, we'll have you charts. You'll have some charts which you'll figure out, and then after a while it'll just become second nature. The second energy level has an s orbital, and s orbitals only hold 2, as we went over. And then the next energy level is a sub-level. It's 2p. Now the p orbital holds up to 6. So that's 8. We know that the second energy level will only hold 8 electrons. And that 8 electrons, here are the 8 electrons, the 2s2 and the 2p6. That's 8 electrons. Those are the only 2 orbitals in the second energy level. The next energy level is 3, and we only have a 3s. And the s holds up to 2. How many electrons is that total? We have 2, that's 10, 12. Well, we need one more electron. So we have to go up to the next, which is a sub-level of 3. We're still in the third energy level. And again, we'll figure out how we place electrons in a second with electron configurations. So we have 3p1. I want to get a diagrammatic view for you so you can see what's going on here. So we have, here's our electrons. That's 13 electrons. Let's look at one more here. Let's look at calcium, or as you guys say, calcium. 2040, protons, electrons, neutrons. All right, so we have 20. In the first energy level, we only have 2 electrons, and we have an s. So that's 2 electrons. So we need a total of 20 electrons we have to place. Why do we care so much about electrons? Because with electrons, that's chemistry. Basically, all your chemistry is with electrons, for the most part. Now the next energy level is 2, of course, second energy level, but now that also has an orbital, a sub-level of s2 as well. That's 4 total electrons. But those other electrons in the second energy level, and I'm going to try and draw this as close as I can, has 2p6. So the second energy level only has a s and a p, and again we'll get to how we know that in a little bit. So we have to go to the next energy level, which is 3. That only has an s orbital. It has an s and a p and a d, which we'll look at in a second. So this has 2 energy electrons. Then we have a sub-energy level with a orbital, a p orbital, a 3p6. Okay, so how many total electrons do we have? We have 10, 18. Now we go to the next energy level of 4, the fourth energy level, and we have 2. So we have 20 electrons. We have an s orbital. Now I'm doing this, you're probably saying, well, how do you know it's an s? How do you know there's 2 in there? How do you know it's p? How do you know there's all that? I'm just showing you this so you can somewhat visualize it compared to the Bohr model of how these electrons are arranged in reference to the orbitals within that sublevel.